What if I told you that hitting the snooze button this morning wasn't actually a failure of your character, but like a symptom of a structurally compromised prefrontal cortex?
Yeah, I mean, that's exactly what the data points to.
Because today we are taking a sledgehammer to this whole idea that discipline is just a moral virtue. I mean, you know that incredibly frustrating experience, right? You set your alarm for 5:30 a.m., you lay out your running shoes, and you make this ironclad promise to yourself that tomorrow is the day your new routine begins.
Right, the classic New Year's resolution energy.
Exactly. But then when that alarm actually goes off in the dark, the person who made the promise is just gone. You hit snooze, you roll over, and then like an hour later, the guilt sets in. You tell yourself, I'm lazy, I just don't have the willpower, I lack character.
It is a devastating cycle. And, the reason it is so devastating is because we have spent centuries, literally centuries, framing that exact moment of failure as a moral shortcoming.
Right, like you're a bad person for wanting to sleep.
Exactly. We've treated discipline as if it were a measure of your soul or your upbringing or just your internal fortitude. But when we actually look at the stack of modern neuroscience research we're exploring today for this deep dive, a completely different and frankly much more forgiving picture emerges.
Which is such a relief, honestly.
It is, because motivation and discipline are not abstract virtues. They are a strict biological choreography. I mean, we are talking about a highly specific, mechanically predictable sequence of hormones, neurotransmitters, and neural network activations.
And that is exactly our mission for this deep dive. We're taking this massive stack of cutting-edge research, the actual mechanics of motivation, neurochemistry, and structural brain changes, and we're going to translate it into a highly actionable, hour-by-hour daily routine.
Right, making it practical.
Yeah, the goal here is to give you the literal instruction manual for your own brain. We want to outline a neuroscience-backed protocol to improve your focus, combat procrastination at the biological level, and actually understand the machinery driving your behavior.
Which is a crucial reframing, I think, because understanding the biology of your behavior, it doesn't diminish your human agency. It gives you the tools to actually exercise that agency.
Yeah, you can't fix a car if you don't know how the engine works.
Precisely. But before we build this daily routine, we really have to recalibrate our vocabulary. In pop psychology, we throw around words like motivation, discipline, and willpower as if they are all just synonyms for trying hard.
Right. They all just mean effort in everyday conversation.
Exactly. But neuroscientifically, they are distinct physical processes happening in completely different regions of the brain.
I think most of us intuitively feel a difference, but let's lock down the actual neurodistinction here. Let's start with motivation. Like, how's the brain defining that?
So at the biological level, motivation is simply the drive or the energetic engagement required to pursue a goal. It's the engine. It is the primitive, highly energized push that gets an organism moving towards something it wants or, moving away from something it fears.
Okay, so it's very primal.
Very primal. It is heavily reliant on our reward circuitry, specifically the dopaminergic pathways deep in the midbrain. Discipline, however, is fundamentally different.
How so?
Well, discipline is a function of cognitive control. It is located squarely in your prefrontal cortex, which is the logical, forward-thinking, evolutionary, newer part of your brain right behind your forehead.
The rational part.
Right. Discipline is the ability of that prefrontal cortex to regulate impulses, suppress immediate urges, and manage competing desires across a long timeline.
So, if motivation is the gas pedal, driven by those older, deeper brain structures, then discipline is like the steering system and the GPS run by the prefrontal cortex.
That's a great way to put it.
So that leaves willpower. How does willpower fit into this machine? Because that's the one we always hear, is this like finite resource that we run out of by 5 p.m.
Yeah, willpower is the emergency brake. It is the highly effortful, computationally expensive capacity to resist an immediate, usually very tempting short-term desire in service of a long-term goal.
Like staring at a donut and forcing yourself not to eat it.
Exactly. And the research consistently shows it functions somewhat like a biological battery. Exerting willpower requires significant metabolic resources in the prefrontal cortex, specifically glucose.
Oh, wow. So you literally burn energy to say no.
You do. When you use it repeatedly to suppress urges, that neural circuitry physically fatigues. So a biologically sound daily routine shouldn't rely on white-knuckling your way through the day with willpower alone.
Because the brake pads will eventually wear out.
Exactly. It should strategically leverage your natural chemical fluctuations so that the right choices just feel frictionless.
Which means we really need to stop treating our daily routine like some sort of test of our moral endurance and start treating it like a biochemical sequence. So let's start at the very beginning of the sequence. The alarm goes off in the dark. How do we physically prime this engine the moment we wake up?
Well, we have to start with cortisol.
Right, and I know the wellness community treats cortisol like toxic waste, but I also know the early morning biology tells a completely different story.
It absolutely does, and this requires us to fundamentally rethink cortisol. To understand the morning brain, we have to look at a mechanism called the cortisol awakening response, or the CORE.
The core, okay.
Yeah. Within roughly 30 to 45 minutes of you opening your eyes, your brain initiates a cascade that triggers your adrenal glands to release a massive pulse of cortisol directly into your bloodstream. It is a profound, sharp biological spike.
Wait, let me push back on this popular narrative for a second, because literally every health blog out there tells you that cortisol is the enemy. It causes belly fat, it destroys your immune system, it gives you anxiety. Why on earth are we trying to intentionally spike the so-called stress hormone first thing in the morning?
Because the health blogs are, quite frankly, conflating two entirely different physiological states.
Right.
We really have to differentiate between acute cortisol and chronic cortisol.
Okay, what's the difference?
Chronic cortisol, which is having your baseline stress levels elevated all day, every day due to psychological stress, is absolutely destructive to your brain and body. We will actually get into the anatomy of that destruction later on.
Sounds ominous.
It is. But acute cortisol, a short, sharp, intense spike, is precisely what wakes you up. When that morning pulse hits, it does a few very specific things. First, it rapidly mobilizes stored glucose from your liver to give your cells immediate energy.
So it's free fuel.
Free fuel. Second, it sharply enhances your sensory alertness by altering receptor sensitivity in your nervous system. And third, it primes your body to physically move.
So it is literally biological espresso.
Basically,
But, caffeine operates by blocking adenosine, the sleepiness molecule. This morning cortisol spike is actually an active mobilization signal. But how do we control it? Because I've noticed a massive difference between waking up in a pitch black room during the winter versus waking up with the sun shining right through the window.
That observation is perfectly aligned with the neurobiology. The cortisol awakening response is governed by a tiny cluster of thousands of cells in your hypothalamus called the suprachiasmatic nucleus.
The suprachiasmatic nucleus, SCN for short.
Yes, the SCN. Think of the SCN as the master clock of your entire body. Now, in your eyes, on your retinas, you have a specific type of cell called intrinsically photosensitive retinal ganglion cells.
Okay, that is a mouthful. What do those cells actually do? I'm assuming they process light.
They do, but they don't help you see shapes or colors. Their only job is to detect the intensity of light, specifically the quality of light that exists in the early morning.
Oh, that's wild. So they just measure brightness.
Exactly. When bright, natural sunlight hits those specific retinal cells, they send an electrical signal directly to the SCN. The SCN then sends a signal down to your adrenal glands, essentially yelling, "Amplify the cortisol pulse." This is why getting natural light in your eyes within the first 30 to 60 minutes of waking is consistently linked in the literature to better energy, better mood, and a higher capacity for sustained focus. You are chemically syncing your internal machinery with the rotation of the planet.
So the very first actionable step in our routine isn't some fancy breathing exercise or a cold plunge. It is literally just stepping outside.
Just step outside.
Wake up, get natural sunlight in your eyes, and physically trigger the SCN to amplify that acute cortisol spike.
Okay.
That clears the grogginess, but waking up is only half the battle, right? Having energy isn't the same as having the drive to go do something difficult, like, going to the gym or starting a complex project. Where does the drive come from?
This is where dopamine enters the chat.
We all know dopamine is going to come up here, but we really need to talk about what dopamine is actually doing.
We do, because we need to completely dismantle the way pop culture talks about dopamine. I mean, the prevailing narrative is that dopamine is the pleasure chemical.
Right. I ate a piece of chocolate and got a dopamine hit.
Exactly. Or I finished my to-do list and got a dopamine rush. That fundamental misunderstanding limits our ability to use dopamine effectively.
I'm really glad you brought this up, because even people who follow neuroscience pretty closely still fall into the trap of associating dopamine strictly with reward receipt. Like, I got the thing, so I feel good.
Yeah.
But the research on reward prediction error takes it to a completely different level. Can you break down Wolfram Schultz's experiments for us? Because that is where this whole pleasure myth just falls apart.
Yes, Wolfram Schultz's work in the late 1980s and 1990s at the University of Cambridge is foundational to modern neuroscience. He was studying monkeys and recording the electrical activity of individual dopaminergic neurons deep in their midbrain.
Okay, so wiring up monkey brains.
Right. And the initial setup was really simple. He would give the monkeys a squirt of sweet apple juice. The monkeys liked the juice, and as expected, the electrodes showed a massive spike in dopamine neuron firing the exact moment the juice hit their tongues.
And if you stop the experiment there, you might conclude, dopamine equals pleasure.
Exactly. Juice equals dopamine, therefore dopamine is the reward.
Right.
But then Schultz introduced a critical variable, a cue. He set up the environment so that a light would flash, and then a few seconds later, the juice was delivered.
Like Pavlov's dogs.
Very similar. The monkeys quickly learned the association. And this is where the recordings completely revolutionized our understanding. Once the monkey learned that the light predicted the juice, the dopamine neurons stopped firing when the juice actually arrived.
Wait, I really want to make sure we underline the mechanics here. You are saying that once the monkey knew the reward was coming, the actual physical consumption of the sweet juice produced zero dopamine spike.
Zero spike from the dopamine neurons they were recording.
That is insane.
It is. The spike completely migrated backward in time to the cue that predicted the reward. Dopamine, therefore, is not the molecule of pleasure. It is the molecule of anticipation. Right. It encodes what neuroscientists call reward prediction error. It surges when a reward is unexpected, or when a cue tells you a reward is coming. It is the chemical that creates the craving, the motivation, and the physical drive to move toward the goal. It is the engine of wanting, not the experience of liking.
That distinction just changes everything. It means dopamine isn't the feeling of eating the cake. Dopamine is the hype man that gets you off the couch, forces you to put your shoes on, and makes you walk a mile in the rain to the bakery to go find the cake.
The hype man is a perfect analogy.
So if we understand that dopamine is the engine of wanting, how do we hack that system in the first hour of our day? We have our cortisol spike from the sunlight, but how do we trigger that anticipatory dopamine spike to get us to actually do hard work?
Well, we leverage the specific mechanics of how dopamine is released. Remember, it encodes prediction error. If an outcome is 100% predictable, dopamine release is actually quite low.
Because there's no surprise.
Right. Your brain doesn't need to be highly motivated for something it completely takes for granted. But you get the absolute highest, most robust dopamine release when the feedback is uncertain.
Uncertain. You mean like the variable ratio reinforcement schedule we see in gambling?
Precisely. It is the exact same neurological mechanism that makes a slot machine so addictive or scrolling a social media feed so compelling.
Right, because you never know what you're going to get.
Exactly. You never know exactly what the next pull of the lever or the next swipe of the screen will yield. That unpredictability keeps dopamine levels elevated, driving you to keep it engaging. But we don't have to be victims of this mechanism, you know. We can use it to manufacture discipline.
How do we practically apply a variable ratio reinforcement schedule to our own morning routine, though? I mean, I can't exactly put a slot machine on my desk.
You introduce variability and challenge into your morning goals. So instead of setting a highly predictable, monotonous goal like saying, I'm going to run on the treadmill for exactly 30 minutes at 5 miles an hour, which offers zero prediction error and therefore low dopamine, you gamify it.
Gamify it how?
You might say, I'm going to run for 30 minutes and see if I can beat my distance from yesterday. Or I'm going to try to finish this coding problem before the timer goes off, but I don't know if I can. You introduce a question mark.
Oh, I see. You are intentionally manufacturing a challenge where the outcome isn't guaranteed.
Exactly.
And I remember the sources highlighting research by Tali Sharot on this exact phenomenon. She looks at how the brain processes optimism and expectation and how we can actually train the brain to associate the effort itself with the reward, right?
Yes. Her work is brilliant. The dopaminergic pathways, specifically the mesolimbic pathway, which travels from the ventral tegmental area to the nucleus accumbens, can literally be rewired through deliberate practice.
Rewired physically.
Functionally and structurally, yes. When you consistently attach dopamine to the pursuit of a challenging goal, your brain begins to release dopamine not just for the anticipated end result, but for the friction of the effort itself.
Wow.
You start to biologically crave the challenge. I mean, Elite athletes or high-level performers don't just love winning. Their neurochemistry has structurally adapted to derive dopamine from the grueling, painful practice. They have turned effort into the reward.
That is profound. So if we synthesize this first block,
Yeah.
we wake up, we get outside into the bright light to trigger the SCN and amplify the cortisol awakening response. We have energy. Then we set a challenging, slightly variable goal for the morning to trigger that reward prediction error, getting the mesolimbic pathway to pump out anticipatory dopamine. The engine is roaring.
Precisely. You have chemically optimized the brain's alertness and drive.
Okay, but here's the transition point where a lot of people, myself included, fail. Having massive roaring energy is one thing, but now it's, say, 9:00 a.m., and I need to sit down at my desk and do the hardest, most complex, most cognitively demanding task of the day.
Right, the real work.
Yeah, I need to write a proposal or analyze data or learn a new software. How do we take that raw dopaminergic energy and narrow it into a laser-focused, immovable work session? Because sitting completely still and focusing on a blank document requires a totally different gear than just having drive.
It absolutely requires a different gear, and it requires a different neurotransmitter. This brings us to perhaps the most critical yet underappreciated chemical in discussions of discipline and deep work, which is acetylcholine.
Acetylcholine. I feel like everyone knows dopamine and serotonin, but acetylcholine sounds like a compound you'd find in a dusty chemistry textbook. What exactly is it doing in the brain when we sit down to work?
So acetylcholine is the primary neurotransmitter of focus, attention, and neuroplasticity. When you sit down, look at your screen, and direct your sustained attention toward a demanding task, a region deep in your brain called the basal forebrain, specifically an area known as the nucleus basalis of Meinert, becomes highly active.
Okay.
It acts almost like a sprinkler system, releasing acetylcholine widely across your cerebral cortex.
Okay, but what is the actual mechanism there? Like when those acetylcholine molecules wash over the cortex, what physically happens to my neurons that makes me focused?
It operates through a process called neuromodulation. When acetylcholine binds to its receptors on the cortical neurons, it alters their electrical potential.
Meaning it changes how they fire.
Exactly. Specifically, it increases the excitability of the neurons that are actively processing the thing you're looking at, let's say the words on your screen. It makes those specific neurons much more likely to fire. But simultaneously, and this is the magic of acetylcholine, it suppresses the synaptic transmission of background noise.
Oh. So it's like turning up the signal-to-noise ratio.
Yes, exactly that.
To use an analogy, imagine being in a massive pitch-black warehouse. Dopamine is the energy that makes you walk into the warehouse, but acetylcholine is like turning on a hyper-focused high-beam spotlight that illuminates exactly one box in the center of the room.
I love that.
It makes the task hyper-visible and physically forces the distractions in the shadows to just fade out of your perceptual reality.
That is a neurologically perfect analogy. It is a literal neural spotlight. But, the reason acetylcholine is the absolute linchpin of discipline goes far beyond just paying attention in the moment. The sources heavily emphasize the work of Dr. Michael Merzenich, a pioneer in the field of neuroplasticity.
Neuroplasticity being the brain's ability to change.
Right. His research demonstrated that acetylcholine is the mandatory chemical trigger for rewiring the brain.
Rewiring as in forming long-term memories or learning new skills.
Exactly. The physical modification of your synapses, a process called long-term potentiation, or LTP. When you are practicing a skill, your neurons are firing together. But Merzenich showed that if you perform a task without focus, meaning acetylcholine is not being released, the practice does not result in structural changes to the brain.
Wait, really?
Yes. The synapses don't strengthen, the skill doesn't stick.
That is terrifying for anyone who multitasks. You were saying that if I am listening to a lecture or trying to write complex code, but I'm simultaneously checking my email and half paying attention, my brain is chemically blocking itself from actually learning.
Yes, that is exactly what is happening. Without the cholinergic spotlight, the brain assumes the information isn't important enough to warrant the immense metabolic cost of building new synaptic architecture.
Because building brain tissue is expensive.
Very expensive. The focused, acetylcholine-drenched state is a non-negotiable biological prerequisite for long-term learning and habit formation. If you want a behavior to eventually become disciplined and automatic, you have to bathe that behavior in acetylcholine during the learning phase.
So the spotlight is non-negotiable. But maintaining that spotlight is exhausting. Which brings us to the next chemical in the deep work stack, norepinephrine. We know it's released from the locus coeruleus in the brainstem, and it acts as the alertness chemical. But the research points to a much more nuanced role during effortful work, specifically regarding a brain region called the anterior cingulate cortex, or the ACC.
Yes, and this is where the neuroscience of effort gets incredibly fascinating. Matthew Apps and his colleagues have done incredible research on the ACC. The ACC is essentially the brain's cost-benefit calculator.
How's that work?
Well, when you are engaged in deep work, the ACC is constantly computing a specific algorithm. Is the energetic cost of this effort actually worth the anticipated reward?
Oh, so it's like the internal accountant of the brain.
Precisely. And norepinephrine modulates this computation. When your noradrenergic system is functioning optimally, norepinephrine signals to the ACC that the effort is acceptable. It lowers the perceived friction of the task. It makes hard work feel doable.
Which explains a phenomenon we have all experienced. Like, have you ever had a morning where you slept terribly, you're stressed, and even the smallest, most mundane task like writing a 3-sentence email feels like trying to move a mountain?
We all have. And what you are experiencing in that moment isn't a collapse of your moral character. Your internal accountant, the ACC, is miscalculating.
Because the norepinephrine is off.
Right. Your norepinephrine levels are likely dysregulated, so the ACC looks at the simple email and computes the metabolic cost of this effort is way too high, abort the task. The friction feels physically insurmountable.
Okay, so we have dopamine providing the forward drive, acetylcholine shining the spotlight, and norepinephrine telling the accountant that the effort is worth it. But when I think about the absolute best work sessions of my life, those rare, beautiful hours where you were writing or coding and you completely lose track of time, it doesn't feel like I am aggressively pushing through friction.
Right. It feels effortless.
Yeah. It doesn't feel like I'm white-knuckling it at all. It feels completely smooth. How does the flow state fit into this intense chemical soup?
To understand flow, we have to introduce a completely different neuromodulatory system, the endocannabinoid system.
Endocannabinoid. As in cannabis. Are you saying the brain produces its own version of THC?
It does, yes. The brain produces endogenous cannabinoids, and one of the most prominent ones is a lipid neurotransmitter called anandamide.
Anandamide.
Yeah. The name is actually derived from the Sanskrit word ananda, which literally translates to bliss or divine joy.
I love that neuroscientists occasionally get poetic with their naming conventions. What does anandamide actually do during deep work?
It acts as a counterbalance to the urgency of dopamine. Dopamine is a craving, right? It is aggressive, forward-leaning, and highly energized. It says, more, now push.
Right.
Anandamide, on the other hand, binds to CB1 receptors in the brain and produces a state of calm, frictionless engagement. It suppresses the neural networks responsible for self-consciousness and hyperanalysis. It literally alters your perception of time.
So if dopamine is the aggressive horsepower pushing the engine forward, and acetylcholine is the headlights illuminating the road, anandamide is like the high-grade synthetic oil that coats the gears so the wheels spin without any friction or heat.
That is exactly the mechanism. When Mihaly Csikszentmihalyi conducted his famous research defining the flow state, that feeling of effortless deep absorption where time dilates, we're looking at a neurological state where the urgent, high-alert chemicals are perfectly smoothed out by the bliss and friction reduction of anandamide. You are highly alert, but completely free of anxiety.
That sounds like absolute perfection.
It is the optimal human state.
So the morning block is locked in. We have our cortisol, our dopamine, our acetylcholine spotlight, and we've coasted into an anandamide flow state. But let's step back into reality for a second. Nobody stays in flow for 8 hours. Usually right around 2.0 p.m. or 3.0 p.m., the anandamide oil burns off.
It always does.
The friction comes back. The task suddenly looks incredibly difficult. You stare at a blinking cursor, and out of nowhere, you feel this desperate, uncontrollable, physical urge to pick up your phone and look at Instagram. The system fails. What biological mechanism just broke down in the afternoon slump?
We have hit the wall. And to understand the biological breakdown of the afternoon slump, we have to completely redefine what procrastination actually is.
Please do, because at 2:30 p.m., procrastination feels like a personal demon.
Right. The standard societal view is that procrastination is a failure of time management. You just aren't organizing your schedule well enough or you lack discipline. But the fMRI research on chronic procrastination tells a radically different story.
What do the scans show?
When neuroscientists scan the brains of severe procrastinators, they find structural differences. Specifically, they often have a larger amygdala.
The amygdala. That is the almond-shaped structure deep in the temporal lobe responsible for fear and threat detection.
Yes. It is the brain's alarm system. And not only is it often larger, but chronic procrastinators frequently show weaker white matter connectivity, specifically in a tract called the uncinate fasciculus between the amygdala and the prefrontal cortex.
Okay, what does that mean practically?
What this neuroanatomy tells us is that procrastination is not a time management failure. It is an emotion regulation failure.
Wait, I really want to make sure I am fully grasping the implications of this.
Yeah.
Are you saying that when I am looking at a boring spreadsheet or a difficult tax document, my brain is registering it as a literal physical threat?
Yes. Your amygdala doesn't just scan for physical predators, it scans for psychological discomfort. When you look at a task that is boring, frustrating, or anxiety-inducing because you might fail at it, your amygdala generates a stress response. It triggers negative emotion. And your prefrontal cortex, the logical CEO that is supposed to step in, suppress the amygdala and say, calm down, it's just a spreadsheet, we have to do this, is failing to communicate that suppression signal.
So to the listener out there right now who is actively beating themselves up for avoiding their work, you are not avoiding the spreadsheet because you are fundamentally lazy. You're avoiding it because your brain's security system is sounding an alarm and your prefrontal CEO is too fatigued to turn the alarm off. It is a structural failure to regulate negative emotion.
Exactly. And when you experience that spike of negative emotion, what does an organism naturally do? It seeks an immediate coping mechanism. It seeks relief.
You reach for your phone.
You reach for your phone. And this introduces a specific type of dopamine dysfunction that plagues modern society, which is temporal discounting.
Temporal discounting, meaning how the brain calculates the value of a reward over time?
Yes. Deep in your reward circuitry, the brain has to evaluate whether to exert effort now for a reward later or take a smaller reward right now. The brain naturally overvalues immediate, cheap rewards, like the instant novelty of a TikTok video, over distant, abstract, future rewards, like the satisfaction of finishing a major project next week.
Which makes evolutionary sense, right?
Yeah.
Like if you are a hunter-gatherer and you see berries right now, you eat them because a promised mammoth next week isn't guaranteed.
Exactly. It kept us alive.
But how does this break our discipline today?
Because in our modern environment, we are surrounded by hyperpalatable, high dopamine digital triggers. These digital environments literally recalibrate the baseline expectations of your reward circuitry.
Yeah, no way.
They teach your basal ganglia and your ventral tegmental area that reward should be instant, massive, and requires zero physical or cognitive effort. So when you put your phone down and look back at the difficult, slow work on your screen, it feels physically unrewarding by comparison. The contrast is just too stark.
The spreadsheet literally cannot compete with the algorithmic slot machine in your pocket. The dopamine threshold has been artificially raised too high.
It cannot compete. And to make matters worse, we have to return to cortisol. Remember how we praised the morning cortisol spike as a good thing?
Right, the acute cortisol awakening response.
Well, by the afternoon, if you are struggling, stressed out, anxious about a deadline, and constantly fighting your amygdala's alarm bells, you are no longer dealing with acute stress. You are marinating in chronic cortisol.
And that's the bad one.
It is. And the research by neuroendocrinologist Bruce McEwen on chronic cortisol is genuinely terrifying for anyone who values their intellect. Sustained elevated stress literally causes a phenomenon called dendritic retraction in the prefrontal cortex.
Dendritic retraction. Let's unpack the anatomy there.
Yeah.
Dendrites are the branch-like structures on neurons that receive signals, right?
Yeah.
Retraction means they are physically shrinking.
Yes. The neural connections in your highly evolved, logical, disciplined prefrontal cortex physically shrink. The arborization, the complex branching of the cells, withers. They lose synaptic complexity.
Oh, God.
But here is the truly insidious part. While chronic cortisol shrinks the prefrontal cortex, it simultaneously causes dendritic growth and hypertrophy in the amygdala.
Wait. So it's like your brain is taking all the funding and resources away from the rational CEO, the prefrontal cortex, and handing a blank check to the panic button security guard, the amygdala.
That's exactly what's happening.
Your brain is physically remodeling its own architecture to become more anxious, more reactive, and less disciplined.
That is the exact anatomical reality of chronic stress.
Mm-hmm.
It shifts you from being a patient, goal-directed planner who can delay gratification to a reactive, threat-based animal seeking immediate relief. You lose your willpower not because you are weak, but because the biological hardware that generates willpower is literally shrinking inside your skull.
Okay, this is a full-blown mid-afternoon crisis. It's
Yeah.
3:00 p.m. Our CEO is losing funding. The panic guard has taken over the building, and we are drowning in a sea of cheap digital dopamine. We obviously cannot just power through this with sheer willpower because the willpower muscle is actively withering.
Right, you can't push a broken car.
We need active biological interventions to lower this chronic cortisol and protect the prefrontal cortex. Where do we even start?
We start by deploying targeted midday interventions, and the first neurochemical pathway we need to activate is serotonin.
Serotonin. Okay, I know this one. The happiness chemical found in antidepressants.
Again, we have to debunk a major oversimplification here. In pop culture, serotonin is just the feel-good antidepressant molecule. But in the neuroscience of discipline and behavioral control, serotonin isn't just about happiness. It is the patience molecule.
Patience.
Yes. It is deeply tied to social status, behavioral confidence, and most importantly, impulse control.
I've always found the link between social status and brain chemistry fascinating. How exactly does status connect to impulse control?
If you look at evolutionary biology, and this applies across species, from lobsters to non-human primates to us dominant individuals, those with high social standing and secure environments exhibit higher baseline serotonergic activity.
Okay, so they have more serotonin. What does that do?
This higher serotonin tone translates to a state of calm assertiveness. Because they feel secure, their nervous system doesn't need to react impulsively to every little potential threat or grab at every fleeting reward.
Because they're at the top, they can afford to wait.
Precisely. In humans, high serotonin provides the patient restraint required to delay gratification. Serotonin pathways actually project into the dopaminergic regions and act as a modulator, essentially putting a gentle brake on the impulsive, urgent cravings driven by dopamine.
So if I am sitting at my desk, feeling the desperate urge to impulsively check my phone or eat a donut, I need to raise my serotonin to apply the brakes. But if my prefrontal cortex is exhausted and my willpower is tapped out, how do I actually do that? Can I somehow borrow someone else's willpower?
You actually can. And this is one of the most powerful, immediate interventions available to us. It relies on the neuropeptide oxytocin.
The love hormone, the cuddle chemical that gets released when you hug someone.
Yes, but its utility in a high-performance routine goes far beyond cuddling. Paul Zach's extensive research on oxytocin demonstrates that it makes social connection intensely rewarding. But structurally, during moments of acute stress, oxytocin triggers what psychologists call the tend and befriend response, which is an alternative to the fight or flight response.
I've heard of fight or flight, but tend and befriend is new. What's happening there?
When oxytocin is released, it travels to the hypothalamus and physically attenuates the hypothalamic pituitary adrenal axis.
The HPA axis. Let's break that down for the listener, because that's the literal stress highway, right?
Yeah.
The hypothalamus signals the pituitary, which signals the adrenal glands to pump out cortisol.
Exactly. It is the chain reaction of stress. And oxytocin acts as a biological roadblock on that highway. In plain English, genuine human connection physically shuts down the production of cortisol.
That is incredible. So if I am stuck on a brutal project at 3:00 p.m., I'm spinning out, my amygdala is screaming, and I'm procrastinating heavily, the absolute worst thing I can do is isolate myself in my cubicle and try to aggressively force myself to work.
It is the worst thing you could do.
The biological hack is to actually get up, go talk to a colleague, join a co-working session, or call a friend who holds me accountable.
Precisely. Using social scaffolding isn't a crutch for weak people. It is a highly effective, targeted neurochemical shield against cortisol. By bringing another human being into your workflow or taking a brief moment for genuine social connection, you stimulate oxytocin release.
And that stops the cortisol.
Yes, that oxytocin suppresses the cortisol that is actively causing dendritic retraction in your prefrontal cortex. You are literally protecting your brain's physical capacity for discipline.
I absolutely love that reframing. Asking for help or working alongside someone is armor for your prefrontal cortex. Okay, so social scaffolding is intervention number one. What else is in our midday toolkit to reset this system?
We must utilize the most potent, broad-spectrum, non-pharmacological intervention known to modern neuroscience, which is exercise.
A midday workout. I know it's good for my cardiovascular health, but what is it doing to my motivation machinery?
It is entirely resetting your neurochemical baseline. Aerobic exercise like going for a brisk run, cycling, or even a fast walk acutely spikes dopamine, serotonin, and norepinephrine naturally, flushing the system with the exact chemicals we need for drive, patience, and alertness.
Like a hard reset.
Exactly. But far more importantly for long-term discipline, aerobic exercise elevates a protein called BDNF.
EDNF, brain-derived neurotrophic factor. I've heard it described as miracle grow for the brain, but what is the actual mechanism? How does it work?
BDNF acts directly at the synapse. It binds to specific receptors called TRKB receptors. When it does, it initiates an intracellular cascade that prevents cell death, supports the survival of existing neurons, and critically encourages the growth of new dendritic spines and synapses.
Wait, so while the stress was shrinking the brain,
Right, while chronic cortisol is actively shrinking your prefrontal cortex, regular aerobic exercise and the subsequent flush of BDNF is actively rebuilding it. It literally increases the structural volume and density of your prefrontal cortex. You are physically building a larger, more robust CEO to handle the stress.
so cardio builds the physical infrastructure of discipline. What about lifting weights? Does resistance training do the same thing?
Resistance training has a slightly different but equally crucial effect. It significantly modulates hormonal levels, particularly testosterone, in both men and women.
And I assume we're not talking about just getting angry.
Right. Contrary to the caricature, testosterone is not simply the hormone of aggression or anger. In the context of the brain, testosterone fuels the drive for mastery, the willingness to exert effort to gain status, and the resilience to overcome difficult challenges.
Oh, that makes sense.
So a routine that combines aerobic conditioning with resistance training gives you the patience and neuroplasticity of serotonin and BDNF, plus the competitive, effortful drive of testosterone.
Okay, but let's be pragmatic here. If I am in an office building at 2:30 p.m., I can't always leave to go for a 5-mile run or deadlift heavy weights. Is there anything I can do right at my desk in 5 minutes to shrink this overactive amygdala and get my focus back?
Yes, you can practice meditation.
Meditation.
And I know the term meditation carries a lot of cultural baggage and can sometimes sound a bit esoteric, but the hard neuroscience backing it up is absolutely undeniable. Sarah Lazar, a prominent neuroscientist at Harvard, conducted groundbreaking fMRI studies on meditation.
What did she find?
She found that a regular mindfulness practice physically increases the cortical thickness of the prefrontal cortex and the insula, which is involved in interoception and self-awareness.
So just like lifting weights physically tears and rebuilds muscle fibers, meditation physically thickens the brain tissue responsible for cognitive control.
Yeah.
But what is happening chemically in the moment you're meditating?
Chemically, meditation significantly increases the brain's synthesis and release of GABA.
Gamma-aminobutyric acid, the brain's primary inhibitory neurotransmitter.
Exactly. GABA's entire job is to quiet down neural activity. It binds to receptors and opens chloride channels, allowing negative ions to flood into the neuron, which hyperpolarizes it, making it much harder for that neuron to fire an electrical signal.
It's an off switch.
Yes. When you meditate and focus on your breath, you release a wave of GABA that washes over the limbic system, physically dampening the electrical firing of the amygdala. You are chemically turning down the volume of the alarm bell.
Wow.
Furthermore, the sheer act of meditating, the process of noticing that your mind has wandered to a distraction and deliberately forcing your attention back to your breath, is a direct, repeated repetition for the prefrontal cholinergic spotlight we discussed earlier. You are practicing the exact neural pathway required for discipline.
So let's summarize this afternoon rescue protocol. When the slump hits, we are going to stop relying on brute force willpower because it's biologically depleted. Instead, we use social connection to trigger oxytocin and apply the brakes to our cortisol production. We use aerobic exercise to bathe the brain in BDNF, actively rebuilding the prefrontal cortex. And if we are stuck at our desks, we use meditation to release GABA, hyperpolarize those fear neurons, and literally shrink the amygdala's threat response.
That is your comprehensive neurochemical toolkit for overcoming the friction of the afternoon.
That is incredibly empowering because it takes the guilt out of the equation and replaces it with mechanics. Okay, so we've navigated the hurdles, we've survived the amygdala hijack, and we have finished the workday. Now we enter the final critical phase of our routine, which is evening recovery. How do we ensure that all these good behaviors become permanently wired into our brain so that tomorrow requires slightly less effort?
Well, the first step in the evening is recognizing the biology of completion. All day long, dopamine was providing the anticipation, the craving, and the drive to push forward. But at the end of a hard day's work, when you finally close the laptop or finish the project, your brain shifts gears. It releases endogenous opioids, specifically endorphins.
Endorphins. We usually associate that with the runner's high after a marathon.
Exactly. But it applies to sustained cognitive work as well. While dopamine is the anticipation of the reward, endorphins are the actual reward signal. They provide the deep biological satisfaction, the profound warmth and contentment of a hard day's work completed.
That feeling when you just sink into the couch.
Yes, that exact feeling. And taking the time to actually feel that satisfaction is a crucial functional step. It serves as a physiological timestamp, signaling to the brain's learning centers that the massive metabolic effort you just exerted was actually worth it.
So taking 5 minutes at the end of the day to review what you accomplished and actually feel proud of it isn't just self-indulgent. It's a necessary biological step to close the neurochemical loop.
It is the final piece of the habit loop. And this brings us to the ultimate secret of long-term discipline, which relies on a set of structures deep in the brain called the basal ganglia.
The basal ganglia. I know they are involved in movement, but what is their role in motivation and habits?
The basal ganglia are a collection of subcortical nuclei that act as the brain's seat of automaticity. The legendary research by neuroscientist Anne Graybiel at MIT mapped out how habits form in this region. She defined the habit loop. A cue in the environment triggers a routine, which results in a reward.
Okay, cue, routine, reward.
Now, when you first start a new disciplined behavior, say, forcing yourself to go to the gym at 6 a.m., you are heavily relying on your prefrontal cortex. It is highly effortful. You are consciously making the executive decision to act.
Right, the first 2 weeks of a new habit are agonizing. It takes every ounce of glucose and willpower you possess.
Exactly. But as you repeat this behavior in a consistent context and close the loop with a reward signal like endorphins, something miraculous happens. The execution of that behavior physically shifts its location in the brain.
Shifts location.
Yes, it moves from the highly effortful, computationally expensive prefrontal cortex, specifically moving out of an area called the caudate nucleus, and shifts down into the deeply automatic, highly efficient regions of the basal ganglia, specifically the putamen.
Wait, it physically relocates in the brain. The software of the habit is moved from the high-energy RAM of the prefrontal cortex down into the low-energy hard drive of the basal ganglia.
That is a perfect way to conceptualize it. What began as a draining, conscious, executive decision becomes a chunked, automatic routine that requires almost zero cognitive effort.
This completely flips how we should view willpower. I mean, the entire goal of using your willpower isn't to just get really good at enduring pain and using willpower forever. The actual biological goal is to make willpower obsolete.
Exactly.
You use your prefrontal cortex just long enough, just for those first few weeks of friction, to safely hand the reins over to your automatic habit system in the basal ganglia.
That is a profound realization, and it is entirely accurate. The truly disciplined person isn't exerting massive, painful effort every single day. They have simply automated the right behavior so they run in the background. But, to build those habits and to synthesize all these neurotransmitters we've talked about today, the dopamine, the serotonin, the acetylcholine, your brain needs raw materials. You cannot build complex neurochemistry out of thin air.
Which brings us to the often ignored variable of discipline, nutrition. What exactly are we feeding this system to ensure it runs?
The amino acids that serve as the fundamental building blocks for these neurotransmitters come strictly from your diet. Your brain cannot synthesize them from scratch.
It has to come from food.
Right. If you want serotonin to give you patience and impulse control, you need dietary tryptophan, found in poultry, eggs, and seeds. If you want dopamine and norepinephrine for drive and focused alertness, you need dietary tyrosine.
And what about the actual physical structure of the brain, the neurons themselves?
For the structural integrity of the neurons, particularly the fluidity of their cell membranes, which allows receptors to function properly, you desperately need omega-3 fatty acids, specifically DHA. Your brain is highly enriched in lipids, and DHA is critical for maintaining synaptic plasticity. Chronic nutritional deficiency, eating a diet devoid of these precursors, fundamentally impairs your motivational hardware.
So relying on a diet of highly processed junk food isn't just bad for your waistline. It is literally starving your brain of the chemical precursors of willpower. Your prefrontal cortex cannot regulate your amygdala if it doesn't have the structural materials to do so.
Correct. But even with perfect optimized nutrition, absolutely none of this machinery functions without the ultimate recovery routine, which is sleep.
I knew we were going to end up here. Everyone intuitively knows sleep is important, but I want the deep biological explanation. Tell me why from a strict neurochemical perspective. What is physically happening inside my skull when I am asleep that makes me so much more capable of discipline the next day?
Okay, during sleep, particularly during slow-wave deep sleep, your brain is performing massive, critical physiological maintenance. First, it clears out adenosine.
Adenosine, the sleepiness molecule we talked about earlier.
Right. Adenosine is a byproduct of cellular metabolism that accumulates in your brain while you are awake. It binds to receptors and creates sleep pressure, that physical feeling of exhaustion. Deep sleep flushes the adenosine out of the receptors, resetting your energy baseline.
Okay, so it clears the fatigue molecule. What else?
Second, and this is a relatively recent, groundbreaking discovery, your brain activates the glymphatic system. During deep sleep, the glial cells in your brain, specifically astrocytes, actually shrink slightly.
They shrink. Why?
This opens up the interstitial spaces between your neurons. Then, cerebrospinal fluid rushes through these spaces via aquaporin 4 channels, literally power washing neurotoxic waste products out of the brain tissue. It flushes out things like amyloid beta proteins, which are a byproduct of waking neural activity.
A biological power wash. That is incredible.
It is vital for cognitive longevity. And most importantly for our discussion of discipline, deep sleep is when the synaptic connections in your prefrontal cortex are restored and calibrated to their optimal configuration. It is when the learning from the day is consolidated.
So if you skip it?
If you skip sleep, you interrupt all three of these processes. You wake up with residual adenosine, neurotoxic buildup, and a structurally weakened prefrontal cortex.
And let me guess the cascade of failure that follows a night of skipped sleep. Your prefrontal cortex wakes up impaired, which means your internal CEO is offline. Without the CEO, your amygdala becomes hyper-reactive to every minor inconvenience. This triggers an early chronic release of cortisol.
Exactly, and this creates a devastating, vicious cycle. Less sleep means higher cortisol and a weakened prefrontal cortex. A weakened prefrontal cortex means terrible impulse control.
Right.
Terrible impulse control means that when 11:000 p.m. rolls around, you are much more likely to stay up scrolling on your phone, chasing cheap dopamine, which means you get even less sleep the next night.
It is a self-perpetuating downward spiral of motivational collapse.
It is. And breaking that spiral by ruthlessly protecting your sleep window is the single most important investment you can make in your biological capacity for discipline.
Okay, we have covered an enormous amount of ground today, unpacking the literal hardware and software of human motivation. I want to pull all of this together and synthesize this daily routine for you, the listener, so you can start applying it tomorrow morning.
Let's review the protocol.
Your neuroscience-backed daily routine goes exactly like this. First, you wake up and immediately expose your eyes to natural morning light to trigger the SCN and amplify that cortisol awakening response. Second, you set slightly variable, challenging goals for your morning block to trigger reward prediction error, revving up your dopaminergic anticipation engine. Third, when you sit down to deep work, you ruthlessly block out distractions to allow acetylcholine to act as a neural spotlight, letting you focus deeply and actually wire new skills into your synapses.
And then, when the inevitable afternoon slump hits, you do not rely on a depleted prefrontal cortex.
Right, you pivot. You lean on social accountability to release oxytocin, which physically attenuates the HPA axis and lowers stress. You use aerobic exercise to boost BDNF and rebuild the dendritic spines in your prefrontal cortex. If you can't exercise, you use meditation to release GABA and quiet the hyperactive amygdala.
It's all about strategic recovery.
Yes. Finally, in the evening, you allow yourself to feel the endorphin reward of completion to encode the habit into your basal ganglia. You eat a diet rich in amino acid precursors like tyrosine and tryptophan, and you fiercely protect your slow-wave sleep so your glymphatic system can wash away the toxins and repair the prefrontal cortex for the next day.
It is a complete biologically sound system for operating your own brain effectively.
It truly is. And before we wrap up this deep dive, there is one final, deeply provocative thought from the source material that I want us to explore. It brings us all the way back to the prefrontal cortex, the seat of discipline.
Yes. There is a critical developmental fact about the prefrontal cortex that changes how we view our entire relationship with discipline. Out of all the structures in the human brain, the prefrontal cortex is the very last part to fully mature. It undergoes massive remodeling during adolescence and doesn't reach full myelination and synaptic refinement until you are roughly 25 years old.
Which explains so much about the impulsivity, the risk-taking, and the intense emotional swings of youth. The CEO is literally still under construction.
It does, but think about what that fully mature prefrontal cortex represents from an evolutionary standpoint. It is the only part of the brain, and perhaps the only biological structure in the known universe, that is capable of reaching forward in time.
Reaching forward in time.
Yes. Your amygdala lives in the immediate present, scanning for threats. Your basal ganglia rely on past habits. But your prefrontal cortex can hold an abstract, detailed image of a future self, a self that does not yet physically exist, and it can actively guide the organism toward that future, suppressing immediate, primitive desires to get there.
So for you, the listener, pondering all of this, understanding your biology, tracking your cortisol, manipulating your dopamine pathways, it doesn't turn you into some cold, deterministic biochemical machine. It is actually the exact opposite. It is the highest possible expression of human agency.
Absolutely.
By deliberately managing your sleep, your stress, and your neurochemistry, you aren't suppressing your humanity. You are tending to the very biological hardware that makes your humanity possible. You are giving your brain the exact fuel it needs to actually become the person you freely choose to be.
You are building the capacity to be the person who, when the alarm goes off tomorrow morning at 5:30 a.m. in the cold and the dark, doesn't hit the snooze button. Instead, you wake up, your neurochemistry aligns with your goals, and you step into the life you planned.
A chemical match rather than a mismatch. Thank you for joining us on this deep dive.